So basically, what do you mean by maneuvering? That too for a satellite or a spacecraft. So basically, we are not dealing with the maneuvering of a spacecraft. We let us stick on with the syllabus. Moreover, it is same, but still we are going to stick on with the satellite. Exactly, we are talking only about the satellites. Okay, so it refers to activity which is being done on a satellite by inducing the propulsion system attached to the satellite in space. Okay, mainly we are doing this for changing the orbit, to maintain the position of the orbit in, or to maintain the position of the satellite in space. Or sometimes if there is a colliding object or a debris, when your satellite is about to collide with a debris, then we used to do all this sort of maneuvering. It is similar kind of like you artificially changing the orbits from maybe the orbital distance, I mean the height, from one altitude to another altitude, changing the orientation, inclination angle I. You may change the inclination. So these are the few maneuvers that you are doing in an satellite. Okay, so basically we why, when, and what situations we do this orbital maneuvers, mainly few things we will discuss. One is rising or lowering of orbit. Okay, rising or lowering of orbits. Mainly, like for example, you may have injected your satellite into an orbit. After injecting, you may not getting the, let us say it is meant for a communication satellite. So maybe you may not be getting the exact coverage with the altitude where you have injected. So in such a situation, you may need to rise or lower the orbit. You need to optimize like altitude where you will be getting the maximum coverage. Before sending the satellite itself, you will be doing numerous studies, but still after post injection, there may be a few disturbances again. So you are still again changing the orbit manually. One situation. Second thing, let us say station keeping. We have discussed about the gravitational pull. Let us talk about the earth let us say it is an earth orbit. So satellite is bounded to the gravitational pull of the earth. So because let us say it is a low earth orbit, because moreover for the low earth orbit, leo orbits, you will be having more gravitational attraction on these satellites because of our gravitational forces. So what happens is, like over a period of time, maybe after years, it happens because of the gravitational force that acts on the satellite. It may change its altitude. It may be attracted towards the earth, which if you are not maintaining the station, if you are not do something on the satellite and to correct the altitude further, it may in a long run it may fall to the earth. So in such a situation, again you need to switch on the propulsion unit, and you need to maintain the satellite in the exact orbit. So station keeping, which is again a important point where you will be doing this maneuver. So basically maneuver is doing some alterations in the altitude by means of height, or sorry, in the orbit by means of height, or by means of orientation, with respect to which is with respect to the earth's equatorial plane and the orbital plane, which is I. Okay, so next one thing can be orbit transfer. You can even analyze about the Chandrayaan mission, where initially we injected into the Earth orbit, then we transferred from the Earth orbit to the Moon's orbit at a particular point where we are doing some maneuvers. We are artificially we from the ground we are switching on the propulsion system in the satellite, and we are doing we are changing the satellite from one orbit to another orbit, right? So this is again a scenario where you do some maneuvers in the orbit. Then next is reduce was docking. This again a scenario. It's like joining. There are certain scenarios where you may need to dock your satellite with another satellite, or to the or your satellite to the international space station, something of that kind. When you need to, very rarely few satellites we are doing this. So in such scenarios also, we are just analyzing the different scenarios where we use maneuvering, where we change the altitude, and we call it as a maneuver. So these are the different scenarios. And another one can be collision avoidance with a debris, or with another satellite, or with a spaceship, or like anything, say, uh, collision, to avoid the collision, or with like another planet, like anything can be possible. Any stars, not stars, any meteoroids or anything, let us say, of that kind. Okay, so in order to avoid the collision, we may artificially again change the orientation from its existing path to a new path, so that it can escape from the collision, right? So these are the different scenarios where we maneuver a satellite orbit, right? So these are the few scenarios. Now let us talk about two maneuvers again, as per the syllabus. So basically, you understood what is maneuvering and what are the different scenarios when we. These are not maneuvering; these are the scenarios where we do maneuvering. Okay. Now there are two types of maneuvering we are using. One is with respect to uh, okay, velocity and altitude, and another is with respect to the orientation. So one is single impulse maneuvering. Okay. Second is plane change maneuver. Okay. So these are the two different. One with respect to, this is with respect to velocity and altitude. You will be changing the speed of the satellite as well as the altitude of the satellite. You may take it up or down, depends upon the situation. So, and you can further, you can increase or reduce the velocity based upon the requirement. This is with respect to the change in inclination angle. Again, this is an orbital element you might have studied already, which is angle between the parent planets equatorial plane. Let us talk about the Earth and artificial satellite. So, Earth equatorial plane with respect to the uh, satellites orbit equatorial, I mean orbits plane, and that angle we have seen already. What is this with when we have seen about the orbital elements? So, if you could change this I, again how we can change, we will just see that. Okay, so single impulse maneuver and plane change maneuver. Okay, so this changing velocity and altitude, we have a method called Hoffman transfer that we will again see in detail. Okay, so single impulse maneuver is also called Hoffman transfer, or we can say it as a Hoffman transfer is a type of single impulse maneuver where we change the velocity and altitude of the satellite. Okay. So if you analyze this, it is like okay. Again, we use this to transfer from a lower orbit to a higher orbit, to transfer a satellite from a low orbit to a high orbit, or from the higher orbit to a lower orbit. Okay, vice versa. Okay. So here what we are doing is we can change the satellite from one elliptical orbit to another elliptical orbit, or from one circular orbit to the other circular orbit. Okay, so we can change from one elliptical orbit to another elliptical orbit, or from one circular orbit to another circular orbit. So here, like mainly it involves the single impulse maneuvering. It involves two bands. Okay, two propulsion bands are involved in this. How we are doing the single impulse maneuvering? Okay, we'll again we will go in detail about the Hoffman transfer with calculations and all those things. But before that, basically we'll see today what do you mean by single impulse maneuver. So uh, here, like two bands you are doing, one at the perigee to increase satellite velocity. So you are using the propulsive band at the perigee to increase the satellite velocity, and other at the apogee to raise the satellite or to a required altitude or a desired. Okay, so single phase maneuvers basically it requires two bands, two propulsive bands, one at the perigee to change the velocity, and at the apogee where you can increase the altitude or decrease the altitude. Okay, so this is all about single impulse maneuver, and we will take the single impulse maneuver further forward with Hoffman transfer and some calculations how what happens exactly with respect to the apogee radius and perigee radius. All those things we will discuss in detail. Okay, in the upcoming sessions. So next is plane change maneuvers. As I told you, plane change maneuvers. Here you are changing the inclination angle of the satellite. Uh, so here. You again you will be using the propulsive unit to change the like del I value, which is angle between the equatorial plane and the angle like angle between the earth equatorial plane and the satellite's orbital plane, which is nothing but I. And this plane change maneuvers is used to change this inclination angle. Okay, uh, so these are the two types of maneuvers we are dealing with. So here, even if you change this I also, finally, like your del V will get changed. So finally, the velocity, the speed, even with the, like it can be the vice versa. With the del V, you can control I as well as it has to be like this. Generally, with the del V, you have to control I. So based upon the velocity, like increasing or decreasing, you can even change the orientation of the satellite as well. Okay, so these are the two things we are taking forward, and in the upcoming class we will see this off-man transfer. So basically, off-man transfer is a single impulse maneuvers where you are achieving velocity and altitude change. So at the perigee, you are achieving velocity change, and at the apogee, you are achieving altitude change. Okay, so these are the basic things that uh, we are going to see in today's session. Okay. So I'll just repeat the things what we have seen today. A very like let us go with again little slow speed, but within a we'll try. Okay, so Hoffman transfer we need to see little more in depth, and we need to solve few problems with related to Hoffman transfer. Okay, which is nothing but single impulse maneuver. Okay, that is mostly off-man transfer is an important topic in your fifth unit, whereas again in the sixth unit you have interplanetary trajectories. Mostly, I'll try to ask Shama sir to take that topic in an online session after maybe on 18th and 19th. Okay, so that is the plan of action. Mm, right. So I'll just repeat today. Like we have seen about orbital maneuvers. We have seen what is a maneuver. Okay. We have seen orbital maneuvers. Know what is a maneuvering of a satellite, and in what scenarios we have seen some different scenarios when we maneuver and satellite. So different scenarios we have seen, like you can just keep in mind like orbit lowering, rising of orbits. You are keeping station keeping, orbital transfer from one elliptical orbit to other elliptical orbit, or from one altitude to the other, or from one planet's orbit to another planet's orbit. So these are the different scenarios. Docking, rendezvous and docking, joining with like a parent satellite, or with uh, any other spaceships or something like that. Again, collision avoidance. To avoid collision, sometimes you need to maneuver the satellite with a power source what it has, which is nothing but the propulsion unit. Okay, so these are the different scenarios, and again we have seen about two things. One is single impulse maneuvers, and other is plane change maneuver. Okay, so this is nothing but Hoffman transfer, which is basically with respect to velocity and altitude. Okay, and here it is with respect to the inclination, which is nothing but the angle between the Earth equatorial plane and the satellite's orbital plane. So changing this inclination, that is what we call as plane change maneuver, and other is changing the increasing or decreasing the speed, as well as increasing or decreasing the height of the satellite. This we call as single impulse maneuver. Right. So these are the basic things. Let us stop with this. Okay.